In this instructional video, we will be focusing on how to use order of operations using the acronym PEMDAS. We will be covering what each letter in the acronym stands for and also walk through different types of examples. A common acronym for PEMDAS is Please Excuse My Dear Aunt Sally. We can see that please stands for parentheses, excuse exponents, my multiplication, dear division, aunt addition, and Sally subtraction. On this slide, we see just how each letter of the acronym correlates with a specific math operation. I included two modes of interpretation to help viewers who might learn in different ways. What's also important about this acronym is how we use it. When working out a math problem, we need to know which operation to find first. PEMDAS will help us figure out where to start. First, we need to start with please, or parentheses, and then work our way through the process and end with Sally, or subtraction, if needed. It's also very important to note that if we have an example where they are asking us to multiply and divide, or add and subtract in the same problem, we always want to work left to right. We will go over that more in future examples. The first two examples are dealing with operations of addition and multiplication. Written in blue, we see the math problem 4 plus 3 times 2. We first want to look at 4 plus 3 in the parentheses because parentheses equals P, and that's the first letter in PEMDAS. So we first want to solve that. So 4 plus 3 equals 7. And then we take that answer and multiply it by 2 to find our answer. So 7 times 2 equals 14. In the green example, there's no parentheses, so we don't have to do the P, and there's no exponent, so we don't need to do E. Our first operation we need to do is multiplication. So we first take 6 times 5, which is 30, and then drop down the plus 6 because M comes before A in PEMDAS, so 30 plus 6 equals 36. In these examples, we're dealing with subtraction and addition operations. So in the orange example, I see 9 minus 7 plus 6 equals. So first, since we do see parentheses, we need to deal with that first. So 7 plus 6 equals 13. And then we drop down the 9 minus, so 9 minus 13 equals negative 4. And I also chose these examples because it can show how adding parentheses to a problem can switch your overall answer. So in the orange problem, we see that our answer is negative 4, but in the purple problem, it's negative 8. So just by taking out, or it's positive 8. So just by taking out the parentheses, it switches which operations we do first. So since we have addition and subtraction in the purple problem, but with no parentheses, we need to work left to right, since those are two operations that we just need to do that way. So 9 minus 7 equals 2, plus 6 is 8. Here in these examples, we're dealing with subtraction and division. In the red example, I see no parentheses, I see no exponents, I see no multiplication, but I do see a division. So first we need to deal with negative 6 divided by 2. So I get negative 3. And then I drop the 10 down, and then I get 10 minus 3 equals 7. In the blue example, I do see parentheses. So I first need to do 8 divided by 2, which is 4, and then drop the 14 down, and I get 14 minus 4 equals 10. In these examples, I am dealing with subtraction and multiplication operations. In the green example, I do see parentheses, so I first need to work through 8 minus 3, which is 5, and then drop the times 2 down to get 5 times 2 equals 10. In the last purple example, I do see parentheses, so we need to subtract 14 minus 3 and get 11, and then do 11 times 3 to get 33. So when working with math operations, don't forget to please excuse my dear Aunt Sally.